Good evening, everyone. Welcome to Grow Pollen Choosers and welcome to the class of Ncert line to line explanation of haloalkanes and haloarenes. In the previous class, we discussed about the introduction of general introduction of haloalkanes and haloarenes. In this video, we are going to discuss about the classification of haloalkanes and haloarenes. If you missed the previous video, please go to the playlist of Grow Pollen Choosers where you can find the playlist of haloalkanes and haloarenes in English. You can watch the first video. Okay. I hope yesterday video is clear to you. Now let us try to understand the today's video, that is classification of haloalkanes and haloarenes. Firstly, what's the need to classify the elements? What's the need to the classification of haloalkanes and haloarenes? If you classify these compounds into certain certain in a certain manner, you can easily study the properties and where it can be used. Okay. Now let us try to understand the what's the concept present in the given NCRT. I am requesting everyone to keep an NCRT with you. It's uh, it's a good thing. Okay, na? Haloalkanes and haloarenes may be classified as follows. Okay. The first one, 6.1.1, on the basis of number of halogen atoms. In the previous video, we discussed that what does mean by halogens? The halogens, which means the fluorine, chlorine, bromine, and iodine. That means simply group 17. Group 17 elements are called the halogens. In the previous video, we discussed that. If the depends upon the number of halogens, the classification is takes place. Okay, now let us explain the classification. These may be classified as mono, di, and polyhalogen, tri, tetra, etc. Okay, compounds depending upon the whether they contain one, two, or more halogen atoms in their structures. For example, here, now let us try to understand the classification based on the number of halogens means if the number of halogen present in the given structure is 1, then it will be named as monohaloalkane. If the number of halogens are present in the structure are 2, this will be categorized as dihaloalkanes. If the number of halogens are present as 3, so 3 means trihaloalkanes. So I hope the basis on the basis of number of halogen atoms is clear to you. It's simply how many number of halogens are present in their given structure. This discussion is all about the haloalkanes. Now let us try to understand what does happens in haloarenes. Haloarenes. This is as same well as haloalkanes. If the given number of if the in a given structure the number of halogens is 1, so it is categorized as monohaloarenes. If it is 2, dihaloarenes, and if it is 3, trihaloarenes. If it is 4, tetrahaloarenes. The only change is that here we observed in these two, here haloalkane, here haloarene is the only change we have to observe that. I hope the classification that is based on the number of halogens is clear to you. Now let us try to understand the next classification. The monohalo compounds. When you observe, these monohalo compounds may further be classified according to the hybridization of carbon. If the carbon is sp3, then classification is different. If the carbon's hybridization is sp2, then classification will also different. To which the halogen is bonded, as discussed below. Here, these two lines explain that if the carbon's hybridization, if the halogen attached carbon's hybridization is sp3, the classification is different. If the halogen attached carbon is sp2, the classification will also different. Here we are going to discuss about the sp3. Firstly, sp3 hybridization, halogen attached carbon having the sp3 hybridization, and next we are going to discuss about the halogen attached sp2 hybridization. The first one we are going to discuss about here, the compound containing sp3 hybridization. That means this halogen attached carbon having the hybridization sp3. Okay, this classification is very important with respect to exam point of view. Now let us try to understand this concept. Okay, the alkyl halides are haloalkanes. This will be pronounced as, this will be named as alkyl halides, or this is the general formula. This type of formula is called the, we call haloalkanes or alkyl halides. Okay, now let us try to understand the main concept. In alkyl halides, the halogen is attached, the halogen atom is bonded to an alkyl group. Exactly. Here we observe that the halogen is attached to this alkyl group. They form a homologous series represented by CnH2n, CnH2n plus 1 into X. They represent the homologous series. What does mean by homologous series? What does it means? Homologous series means if you observe two compound, here is the compound A, here is the compound B. That means the structure A and the structure B. We observe that CH2 group is difference. The difference of when you observe the structure A and the structure B, we observe the CH2 group is difference. Now let us try to understand. Here by taking an example, here is the compound CH3, CH2, CH2 bond Cl, and here in this case CH3, CH2 bond Cl. Here we observe that the missing of the difference of one CH2 group. This type of compounds we call as homologous series. I hope this concept is clear to you. Now let us try to understand the next concept. Here we observe that this general formula is belonging to the hydrocarbons. That means CnH2n plus 2. But we observe that, okay, for example, here Ni value is 2, then it will become C2H6. Okay, this concept explain with by taking up on whiteboard. Okay, we observe the general formula. We observe that CnH2n plus 1 into X. This is the formula, general formula for alkyl halides. Alkyl halides. We observed that this alkyl halides formula is derived from the hydrocarbons. We know that the general formula of here, the general formula for alkanes. The general formula for alkanes is CnH2n plus 2. Okay. Here we observe that one of hydrogen is replaced by halogens. That's why here one hydrogen is missing. Okay, now let us explain this concept by taking example. If the n value is equal to 2, so it becomes C2H6. We can write it as CH3, CH3. So it will this ethane. Its name is according to IUPAC nomenclature. Its name is ethane. This ethane is reacted with the chlorine gas. So we observe that one of hydrogen is replaced by chlorine. So the product is CH3, CH2, Cl, and liberated as HCl gas. Okay, in this way, we observe that one hydrogen is missing from the hydrocarbons. That's why here we observe the general formula of alkyl halides becomes CnH2n plus 1 into X. Here, the general formula of hydrocarbon is CnH2n plus 2. But here, CnH2n plus 1. Why? Because one hydrogen is replaced by chlorine atoms to form the alkyl halides. I hope this concept is clear to you. Okay. They are further classified as primary, secondary, and tertiary according to the nature of carbon to which the halogen is attached. So, among these, we can observe that if the if the halogen attached carbons are further classified into three types, that is primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. If the halogen is attached to primary carbon atom in alkyl halide, the alkyl halide is called the primary alkyl halide and a primary alkyl halide. Similarly, if the halogen is attached to second or tertiary carbon atoms, the alkyl halides is called the secondary alkyl halide and the tertiary alkyl halides respectively. Okay, firstly, now let us try to understand what does mean by primary alkyl halide. How can you identify if the given compound is a primary alkyl halide, secondary alkyl halide, tertiary alkyl halide? Okay, this concept will explain by taking off an whiteboard. Okay. Now let us take an example here. Here R means alkyl group. Here R means alkyl group. What does meant by alkyl group? The alkyl group which means the bond CH3, bond C2H5. This type of compounds are called the alkyl. Here its name is methyl. Its name is methyl. Its name is ethyl. Propyl, butyl, so on. Okay. Bond C, bond hydrogen, bond Cl. Okay. You have to remember that whenever halogen attached carbon having two hydrogens, this concept in a previous video, in introduction video also, we are also discussed. Now let us try to understand how can you identify if the given compound is primary, secondary, tertiary alkyl halide. You have to remember one point that the halogen attached carbon having sorry, the halogen attached carbon having two hydrogens. If the halogen attached carbon having the two hydrogens, so it will categorize as a primary alkyl halide. So it is categorized as a primary alkyl halide. Okay, clear. I hope this concept is clear. Now let us try to understand the second one. Bond C, bond R dash, bond hydrogen, bond Cl. Here R dash which means, for example, this R is different from this R. That's why we put the dash here. So now let us categorize. This R is a CH3 and this R is a C2H5. Okay. So when halogen atom, okay, here I observe that when halogen attached carbon having only one hydrogen, this type of compound is categorized as a secondary alkyl halide. This type of compound is categorized as a secondary alkyl halide. Now let us try to understand the tertiary alkyl halide. Here are bond R dash, here R double dash is attached to chlorine. If the halogen attached carbon having does not having any hydrogens, here does not having does not having any hydrogens does not having any hydrogens, this type of compounds we categorize as tertiary alkyl halides. Tertiary alkyl halides. I hope this concept is clear to you. How can you classify it as if the given compound is primary, secondary, tertiary? If you have any confusion about this concept, I hope this concept is clear to you. If the halogen attached carbon, you have to see the point that if the halogen attached carbon containing two hydrogens, then it will categorize as a primary alkyl halide. If the halogen attached carbon having the one hydrogen, so it is categorized as secondary alkyl halide. If the halogen attached carbon does not containing any hydrogen, so we can easily categorize it as a tertiary alkyl halide. I hope this concept is clear to you. Now let us try to understand the given concept. Okay, so this is primary. So we observe that here hydrogen, two hydrogens are here. The halogen attached carbon having the two hydrogens. So simply we put primary. Here the halogen attached carbon having the only one hydrogen. So secondary. So halogen attached carbon having the only one there is no presence of hydrogens. That's why we categorize as secondary. Sorry. So you categorize as tertiary. I hope the first classification from carbon attached halogen attached carbon having the hybridization sp3. Now let us try to understand the second one, that is allylic halides. Here, what does mean by allylic group? The allylic group, which means simply the CH2 double bond CH bond CH2. This group is categorized as allylic. This group is categorized as allylic. Here we use the halides. That means here CH2 is bonded to halogens. That's why we use the word allylic halide. So you have to clear about this concept. What does mean by allylic linkage means? Allylic means CH2 double bond CH bond CH2 bond halogen. So up to this is called the allylic. Up to this is called the allylic one. I hope this concept is clear to you. Okay, these are the compounds in which halogen is attached to the bonded to an sp3 hybridized carbon atom adjacent to the double bond, that is allylic carbon. So here we observe that the halogen which is attached to this carbon having the hybridization sp3. So adjacent to this carbon, the hybridization is sp2. Here, if you have any doubt when identifying, please listen carefully. If you have any doubt in identifying the allylic halides among the given options, okay, you have to identify that the halogen attached carbon must be sp3 hybridization and the adjacent carbon must be sp2 hybridization. So you have to remember that the halogen attached carbon must be sp3, the adjacent carbon must be sp2. So this type of hybridization takes place only in allylic. So we can easily identify that. Okay, here is the form. This form is also written as in this way. Okay, now let us try to understand the aromatic ring type of compounds. Here we observe the simply here ch bond ch, here bond ch2 linkage. So in the straight chains, we does not have any confusion. But in the ring type of compounds, we have to carefully observe the allylic carbon present or not. Here we observe CH2. Here in CH place, another CH is attached. So CH2 bond halogen. Now let us try to understand this trick. The halogen attached carbon having the sp3 hybridization. So adjacent. So I hope you know that when carbon is singly bonded, so it is categorized as sp3 hybridization. If the carbon having the double bond, this carbon having the sp2 hybridization. If the carbon having the triple bond, these are categorized as sp3, sorry, sp hybridization. So by this concept here, we observe that single bonds are present around this carbon. Here we observe that this carbon having the single bonds here one, two, three. So three sides. 1 minute, please. Okay. So we observe that this carbon having the three single bonds here, one hydrogen is present. That's why this carbon hybridization is sp3. Here we observe that double bond, which means the carbon hybridization is sp2. So we observe this trend sp3, sp2. So this is an allylic carbon. This is an allylic carbon. Okay, now let us try to understand the third classification, that is benzylic halides. Okay, these are the compounds in which halogen atom is attached to sp3 hybridized carbon atom attached to an aromatic ring. We haven't confusion about allylic halides and benzylic halides. There is no confusion in that. Allylic means the hybridization must be sp3 and sp2. Okay, the next one. Here also we observe that the halogen attached carbon is sp3 and the adjacent carbon having the hybridization sp2. But here we observe one thing, that in benzylic we observe the benzene ring. Benzylic, which means we observe the conformly benzene ring is present. But in allylic there is no condition of presence of benzene ring. So these are present in this form. So the major difference is that the benzylic halides which must and should contain this benzene ring. Okay, this is categorized as primary. So how can you categorize this halogen is a primary, this alkyl halide is a primary? We have the simple trick that the halogen attached carbon having the two hydrogens. So it is categorized as a primary alkyl halide. So we can simply categorize it as a primary alkyl halide. And in the second case, we observe that this halogen attached carbon, here we observe that there is no presence of hydrogens. So this is simply categorized as a tertiary alkyl halide. Tertiary alkyl halides. Okay, I hope the classifications what does mean by alkyl halides and haloalkanes, and second one is allylic halides, third one is benzylic halides. Okay, now let us try to the last classification, that is the halogen attached. Okay, the halogen attached carbon having the hybridization is sp2. Okay, only two classifications, that is vinylic halides. So whenever CH2 double bond CH and immediately halogens, so this group is called the vinylic group. This group is called the vinylic. This form is present whenever we encounter this type of form. We name it as a vinylic group. These are the compounds in which halogen atom is directly attached to sp3 hybridized acid, sp2 hybridized carbon atom of carbon-carbon double bond. So we observe that this halogen attached carbon's hybridization is sp2. So we name it as vinylic halides. So in ring structure also we observe that this halogen is directly attached to sp2 hybridization. So this classification is called as vinylic. This classification is called the vinylic halides. Okay, I hope vinylic halides clear to you. Okay, the last one is aryl halides. The aryl halides, which means aryl means benzene. The must and should benzene is present. The must and should benzene is present. These are the compounds in which halogen is atom is directly bonded to sp2 hybridized carbon atom of aromatic ring. So we observe that this halogen is attached directly to the benzene ring. That means sp2 hybridization. That means sp2 hybridization. So here also we observe that halogen is directly attached to carbon. This hybridization is sp2 hybridization. So this type of classification we call as aryl halides, and the next classification is vinylic halides. These halogen atoms are directly attached to sp2 hybridization. I hope the classification of haloalkanes and haloarenes is clear to you. If you have any doubt in that classification or introduction video, feel free to contact us or message me. I will available on WhatsApp, and I will talk to you if you have any problem, personal problems with respect to subject, how to plan and how to. And if you found this video is useful to you, please do subscribe for more videos and updates, and please share with your friends and family members. You have to remember that sharing is caring.